in example 12, we have a balloon. We're going to just assume it's a perfect sphere. That'll make the problem easier. This spherical shaped balloon is being inflated such that the radius is increasing at a rate of 2 millimeters per second. Assume initially the radius is, and I notice I forgot the word is, 0 millimeters. Again, that'll make the problem easier, even though probably it's not perfectly 0 millimeters, right, to start off with. But initially it's 0 millimeters. That means at time, at the beginning time, when t is 0, the radius is also 0. So write the volume of the balloon as a function of the time, which we're going to call t. I already said t is 0. Okay, so when t equals 0, r is also 0. That's what this part is meaning. So we have, let's see, we want the volume of the balloon as a function of time t. We know from geometry, we know that the volume is equal to 4/3 pi r cubed. So the volume is a function of the radius, not a function of time, right? But in this particular case, we have a relationship between the radius and the time. We know it's increasing at a rate of 2 millimeters per second, and this is a constant rate. So we can write a formula for r in terms of t. What is the relationship between r and t? Well, we know that the radius is increasing at a rate of 2 millimeters per second, and if we know how many seconds have passed, we can find the length of the radius. We would just multiply times t seconds. Notice the seconds cancel and we just get the radius is 2t millimeters. So if we know that r is equal to 2t millimeters, we can plug that in to our formula for the volume. Which means we're going to have to cube it. We get 4/3 pi times 8t cubed. And 8 times 4 is 32 thirds. Oh, what did I do here? I'm sorry. Parentheses are... Oh, no, I wrote that right. The parentheses are in the right spot. 4/3 times 8 is 32 thirds. And then we've got the pi, that's also a constant, and then t cubed. Now the volume, if we know how many seconds have passed, we can find the volume. That's a 3, sorry. All right, volume is 3-dimensional, and then this would be, millimeters cubed would be the units if we actually did know the time. Let's see, what was I going to say? Oh, the domain. Keep in mind then t would have to be bigger than or equal to 0 here for this to make sense. If, no time has passed, then there's no volume. But as t is increasing, the volume's increasing. Of course, there would be some sort of constraint. Eventually the balloon would pop, but we'll ignore that. All right, our last thing here. In calculus, we have a really important formula called the difference quotient. And here it is. I could have spent some time explaining it to you, but I'll leave that for your calculus class if you're going to take it. So we're just going to deal with the algebra part of it, because when you get there, you're going to be expected to know how to algebraically handle this. So if you have a function and it says find and simplify the difference quotient, you're expected to, you do this, which is all just function notation here. So even without understanding what this represents, you can handle the algebra, right? So we'll worry about understanding that when you take calculus, but for now, just understand the algebra. So f at x plus h minus f at x all over h. We already did a problem where we had the x plus h. So just take that part and handle it separately from this. F at x plus h, we're going to put all these, replace all these x's with x plus h. So we've got 2 times x plus h squared minus 3 times x plus h plus 1. I'm going to just put a bracket around here to show that's this part here. Now we're going to subtract f at x. This part is actually easier because f at x is given. We don't need to do anything but write down 2x squared minus 3x plus 1. The one thing you do need to remember though is you will have to distribute the sign through that, so put parentheses around it. And then this is all over h. When you do this, a lot of students get lazy and they don't want to write everything down for each step. I want to see everything. Don't leave the h out of 5 of your steps and then it reappears in steps, 6 or whatever. Want to see it in every step. Okay, so we already did one like this where we squared this and, recall the result was x squared plus 2xh plus h squared. That's always going to be the same. Minus, well, assuming you're squaring. It could be a different function and a different rule, right? But for the quadratic ones, when you're squaring, you're going to get this. Minus 3x minus 3h plus 1. So I've distributed the negative 3. Here I'm going to distribute the sign, negative 2x squared plus 3x minus 1 all over h. Writing every part completely, not partial steps. Now distribute the 2x squared plus 4xh plus 2h squared minus 3x minus 3h. I know it's a lot of writing, but write it all down anyway. That's how you get better. And you want it so when somebody else comes and reads it, they can understand your work. All right, all over h. Now, if you've done this correctly, a lot of things will balance out, in other words, cancel. 2x squared minus 2x squared, notice that adds up to 0. Negative 3x plus 3x adds up to 0. 1 minus 1 adds up to 0. And everything that's left has h in it. Write those down here, 4xh plus 2h squared minus 3h all over h. In the difference quotient, notice that this says where h is not 0. That's because we can't divide by 0. And if h isn't 0, then we can cancel it out. So if we factor h out of the top, cancel it out, our final answer is 4x plus 2h minus 3. And we're done. Okay. So in some of your homework problems, there's actually some easier problems where the x's are a constant, like if this is 2 plus h and this is f at 2. It's actually a little easier because you can find what f at 2 is and then you just get a number for the second part. So don't be confused by those problems. This is with the variables is actually harder, but it should, kind of simplify the same. When you do these, things should cancel so that you can cancel out that h. If there's if you just, what a lot of people will do is they'll forget to distribute the sign. So like now you've got a plus 2 here instead. Well, you can't cancel h if this 2 doesn't have an h in it. So that means, that's a clue that you did something wrong. So be careful with your signs in your algebra. Don't forget this middle term. Don't forget to distribute correctly. Okay, that's it.